Hi everyone, in this video we're going to discuss our Mid Sem test. For question 1, given a complex number z equals to a plus bi, where a and b are real numbers and z bar is conjugate of the z. For the question A, find z, means you have to find out what is your complex number here. Given here, our equation will be z minus z conjugate times 4 minus 5i equals to 2 minus 3i over I power 4. So we substitute the z in the form of a plus bi. At the same time, conjugate of z, a minus bi. And then I to the power of 4 is positive 1. So from here, we need to find out what is our a and what is our b, so that we can form out our complex number. So first of all, we're going to do our multiplication of the complex number here. We're going to expand this. So here we have for a, negative become positive, 5ai, and then here negative, with the negative here positive, for bi, and then expand to the back here will be negative become positive times negative 5b I squared. So I squared, we directly substitute it as negative 1. Then we collect our term, which one is our real part and which one is our imaginary part. So with our real part, we have 4 minus 4a, a minus 4a, and then plus 5b equals to real number 2. Therefore, we have negative 3a plus 5b. So that will be our real part. Then we collect our imaginary part. So we have b plus 4b, 5b. And then here we have 5a. So 5a plus 5b I is equals to 2 minus 3i. Then we start to compare to build up two equations so that we can find the unknown a and b. Real part, negative 3a plus 5b equals to 2. Imaginary part, 5a plus 5b equals to negative 3. Then we do elimination method. We have 5b that is similar. So therefore, we will take equation 1 minus equation 2. So we have negative 8a here at the right hand side. 2 minus negative 3, it gives us positive 5. So therefore, a is negative 5 over 8. Then we're going to substitute into either one equation. So for here, I pick equation 2 in order to find out the b. So b will be 1 over 40. Therefore, answer the question, what is our complex number? It will be negative 5 over 8 plus 1 over 40i. So that will be our part A. Then go for the part B. Hence, find the argument of the conjugate of the complex number. First of all, we state out the conjugate of the complex number. It will be negative 5 over 8 minus 1 over 40i. So to find the argument, we need to know what is our Argand diagram. So in Argand diagram, negative 5 over 8 and negative 1 over 40, this complex number is fall in quadrant 3. When our complex number fall in the quadrant 3, so the argument for this complex number, it will be in the formula of negative pi minus alpha. So alpha is our basic angle where we can obtain it by shift tangent b over a. So b over a here is 1 over 40 divide 5 over 8 without negative. So for inverse trigo, we won't have any negative value beside the inverse trigo here. Then we just need to press our calculator in mode radian. We don't want our answer in degree, so that will be our condition of the argument. All the argument need to be in radian. So here we have 3.102 negative. So give more decimal place. Give more than 3 significant figures. So here we have our question 1. Then we see what is important concept here. For the first part, it will be important that we know how to substitute our complex number, and we simplify our complex number to get our equations. So since I will get our equation, then it will be the concept of solving simultaneous equation to get value of A and value of B in the answer, then put in the complex number form. Then for argument, in quadrant 3, we need to use the correct formula where this shift tangent, we should not put any modulus or any negative value. Although the coordinate here is negative, but for basic angle, we didn't take negative value. Then our answer will be this. Then for question 2, we're going to find the interval of x for the inequalities below. So first of all, we can see our denominator is in modulus, means it's always positive. So for this denominator, which is in modulus, we can cross multiply it to the right hand side. So that is the only condition with the modulus for the denominator part here. So without modulus, we can't do that. So first of all, we simplify our equation first, inequalities here. So 2 multiply, it can be multiplied to the right hand side because 2 always positive. It won't be disturb our symbol of inequalities. So times 2 equals to 6. Then for denominator and numerator, which is both also modulus, we can split it and we rearrange it to the right hand side so that we have the pattern where we have both side modulus. So both side modulus will be solved easily than using basic definition. So for both side modulus, we can do squaring both sides. So when we remove our denominator position to the right hand side, make sure you write the condition for our denominator that it cannot be 0. So that is the first part of our answer. Our x cannot take equals to 0. Then for the symbol of modulus, we change it, become square root and square. To remove square root, here we have our method squaring both sides. So with that squaring both sides, now we're leaving x minus 9 square. Then 36 x squared. Then we're going to expand our quadratic. Now we have our quadratic inequalities. For quadratic inequalities, we need to rearrange our quadratic all to the left hand side. So we expand this. And we notice that our quadratic is in negative, where we cannot factorize yet. We need to divide it by negative. So we always get a positive quadratic in order to use calculator to help us factorization. So when you divide by negative, we need to change sign. Therefore, when we get our quadratic inequalities, the next step is factorization, drawing the graph, and then shape the region. So factorizations here, it gives us 7x minus 9, 5x plus 9, and we put in our roots here in order, smaller at the left hand side, bigger at the right hand side. So negative 9 over 5 at the left hand side, 9 over 7 at the right hand side. And then in order to get our answer, we need to shade our region less than 0. So that less than 0 is a region below the x-axis. And then don't forget, just now we have a precondition where our denominator cannot be equals to 0. So 0 is in the middle here, so we should not include this value of 0. Then finally, we write out our answer in interval because it said find the interval of x. So the interval of x will be negative 9 over 5 until 0. So 0 is not included. Negative 5, 9 over 5 is included. Continue, take out the 0, not included, until 9 over 7, which is included. Then we see what is important here. First of all, when you move your denominator to the right hand side, forming modulus both sides. So remember to state out your precondition where denominator is not equal to 0. Then squaring both sides, expand these inequalities correctly. Then factorize, forming your quadratic. Then you factorize, drawing your graph correctly. And shape your region correctly. Then finally, this is your answer. Next, continue. So we are going to find the solution for this equation. So given that if you have log base a to the power of log base a, they are same base here, it can be simplified into b. So for doing this, we can notice that we have indices base 3. Then in the power of log base 3, we take out the coefficient 2, become the power of x. Then we can simplify this log 3 and then base 3 given you x squared. Then continue. For this, x of the power 81 here at the power here, so x here can move into the front using the properties of the log. Then log 381, this is our number. We can figure it out. What is your final number here? Equals to negative 3. Then we simplify. So here we have x squared. When we press calculator for this log 381, it gives us 4. So this is 4x. And then move the 3 here, become positive 3 equals to 0. So we have some typo here. This is negative. Then we continue. After we get this quadratic, the next step will be factorization. And x will be equals to 1. X will be equals to 3. So both of these will be our answer. So we just need to check x in the log. As long as the x here is positive, so this log is valid. And log 3 also valid. Then in the power indices, it won't have any problem. So as long as this log is valid, so both answers will be accepted. Continue for part 2, indices equation. First, we can simplify our indices, where these indices, it can be 2 to the power of x, where this 4 we can change it to the 2 to the power of 2x equals to negative 2, and we can let these indices become n. So here we have negative m squared followed by n. Negative 2, we move it to the left hand side, and then quadratic is negative. We simplify this quadratic before pressing calculator. Then we do factorization to find out our m value. So therefore we have m equals to negative 1, m equals to 2. Then we substitute back our m is 2x. So obviously here we can compare its power, so x is equals to 1. And here, when we want to find the x, we log the 2 to the right hand side for this negative 1. Here it gives us invalid because log cannot bring any negative value. So therefore, we only have one answer as x equals to 1. Then we see what is important step here. The first one, using the properties of logarithm, simplify it to be x squared. Then continue. So this is the form of the logarithm, simplify it. And then continue forming out our quadratic equation. Factorize the quadratic equation. Okay, then we get the answer for both x. Then when for indices, firstly, we simplify our indices of the equation here into base 2. Then we will obtain a quadratic where you need to factorize to get the answer. So to get the answer, we need to substitute back our indices here. Then we can notice one is invalid, one is valid. So this is our final. Then next, for this question, we are given a quadratic function. And this quadratic function with condition x more than 4. So be careful here. This is not a general function. It's just leaving some part from the quadratic only. First of all, they ask us express this function in the completing the square form. Then we're going to state its domain and range, find its f inverse and its domain and range. Hence, find the value of x given the equations here. So first, we need to express it in completing the square form. First of all, the value of a in front of this quadratic, you need to be factorized out. So take out the 3. Then we only do the completing the square for this quadratic where the coefficients start with 1. So we put in the completing the square bracket x to the power of 2. Then for this value b, we're going to divide by 2. So we get negative 3. We minus back the value that we put in the bracket square here to remove the expansion value, which is 9 here. Then the last one, 7, we just follow. So after that, we simplify the constant at the back here. So negative 9 plus 7, it gives us negative 2. Then don't forget, put back your 3 that you factorized just now. So here it will be our completing the square form for quadratic. So in function, we didn't use the expansion form. We will always refer to its completing the square form. Therefore, we continue for the part B, state the domain and range. So state the domain and range, normally we will use domain DSLR, range Castle. In the scope of this question, we can't use this formula as well because we just remaining some part of the graph. So when you just remaining some part of the graph with the condition come in, we need to see what is your new coordinate here, which is the remaining part of the graph that we need to see their domain, its domain, and its range. So generally, we will still drawing for the whole graph. So for domain, generally for the function, quadratic is not special case. So for range, it's a special case. So for range here, when we close this quadratic, we see negative 6. Negative 6 included to infinity. So from here, we know that our quadratic graph is going up. So going up with the minimum point, x equals to 3, y equals to negative 6. So here we have our y-axis to get positive 3. And then here will be our x-axis. So just draw it, sketch it only. So this is our 3, this is our negative 6. And then what we need to do here, we focus the condition from the question. Condition say that more than 4. So we want the graph after 4 here. So we want the graph after 4 here. So your quadratic is still going up. So here will be your remaining part. So focus on your graph, the domain of your function according to the condition from the question. X is more than 4, so 4 to infinity. Range for the graph, you need to know what is your minimum value here. So when x is equals to 4, your function substitute for what is the coordinate. So it will give you negative 3, means that this point is 4, negative 3 will be remaining. So other than that here, this is not involved. So look at your graph to find the range. We observe from the bottom. The bottommost from the graph is negative 3. Then going up is infinity. Since this point is not included, means that this point 4, 3 should be empty circle. Then going up. So domain start with 4 not included to the right hand side. Range start from the minimum point, negative 3 not included to the infinity. So here we have our domain and range. Then continue. For C, we're going to find its inverse and domain and range. So to find inverse, we will use composite method where f inverse x equals to x. So we no longer using the SPM method where f inverse x, let it equals to y. Alright, so please take notes here. Don't repeat the same method from the SPM. So what we need to evaluate here is using your composite method. And substitute your f inverse to your function. So the function we use here will be using the computing the square function. Therefore, we'll have 3, then f inverse x minus 3 squared minus 6 equals to x. We try to remove everything until we get this f inverse. So firstly, we plus 6. Then we divide by 3. So here we have f inverse minus 3 squared. Then when you want to remove our square to the right hand side, don't forget we always got two answers to solve the quadratic. So quadratic, when you want to solve it, you have positive and negative answer. So of course not the both answer we're going to accept, because if you have this quadratic, it will not be one-to-one function. If you're taking the whole quadratic, it will not be one-to-one function. Of course, definitely that the inverse will not exist. So therefore, this question is prefer to use one-to-one function where the domain start from 4. You can see when the domain start from 4, this quadratic is one-to-one function. So that's why we can find its inverse. So since our domain is more than 4, therefore f inverse only taking the positive part. Then lastly, we move the 3 to the right hand side. So therefore, that will be our f inverse. Then to find the domain of f inverse, we refer to the range of the function, which is negative 3 to infinity. And to find the range of the f inverse, we refer to the domain, which is 4 to infinity. Next, we're going to find question D, where it asks us to find the x when f inverse is equals to 5. So when f inverse function equals to value of 5, means this answer will be equals to 5. Then we simplify here. Move the 3, we get 2. Move the square root, we get square. To remove the square root, we square both sides, so we get square. So this x will be 4 times 3 minus 6. So here we have 6. Then we come to our important step here. So what is important at the beginning of computing the square? Firstly, factorize out the 3. It's not divide your 3. Here is a function, it's not equation. Alright, if this one is equation equals to 0, you can divide by 3. But this one is an expression of function, you can't divide by 3. So therefore, factorize your 3. Then start your computing the square to get this form of the answer. Then finding out your domain and range under the condition status here. Then find our f inverse using composite method. Simplify it, we need to see you having 2, positive and negative, and you pick for the, with giving the reason, you pick for the positive and simplify the answer. Lastly will be your domain and range. Then for solving this equation, substitute your f inverse, let it equals to 5, then simplify to get your value of x. Then we continue for the question number 4 here. It said the function fx and gx are defined as logarithm function and exponential function. Then for the first one, show that by using algebraic method, fx is one-to-one function. So by using algebraic method means we need to substitute x1 into the function, let it equals to substitute x2 into the function. We try to simplify, find out what is your x1. So when you move our 3 to the left hand side, showing this step by step. Alright, so this is the question of solving. So you must show it step by step, how you remove all the function until you get the x1 only. So negative, simplify. Then you unlock both sides and you divide by 2. We can notice that x1 is equals to x2, only one answer. Do our conclusion saying fx is an 1-to-1 function. So here will be important that you're stating out your conclusion instead of just writing a shown. Alright, so we must have the conclusion in showing one-to-one function. Then for question B, by using composite function, by finding its composite function, you need to determine whether the function is it inverse or not. So what you need to do is finding your fgx, finding your gfx. You have to observe these two composite functions, whether getting the same answer. If they are getting the same answer, mapping back to x, yes, this function and gx are inverse to each other. So we start with our composite, substitute gx into fx. So means the place of x here will be replaced with the things in the bracket. And then we can start simplify. So means 2 need to multiply with this. So 2 times 2 we get ln. And then ln will be simplified. We get just only 3 minus x. So ln e we get 1. Finally 3 minus 3 plus x, we get x. Then we done. So we get fgx mapping back to x only. Then we have to observe and calculate for gfx. So substitute the fx first. Then substitute this into the gx, means the place of x here, in the power place. So in the power position, we simplify 3 minus 3 is positive. Negative, negative become positive. Then e to the power of ln x is equals to 1. Therefore, we have remaining 1 over 2 times 2x. Then we simplify, it is also equals to x. So when we have these two composite answer is equals to x, here we can do the conclusion saying that fx and gx are inverse to each other. So once again, write down your conclusion. So we done for that. Then question C, we're going to find out the domain of f and gx. So since the function of fx and gx are inverse to each other, means f inverse is gx or g inverse is fx. Therefore, we can refer their domain. So we find for domain fx first. For the domain of fx, ln. Ln, so what is the ln bring here, which is 2x, must be always greater than 0. When we simplify, it will be greater than x greater than 0, which is 0 to infinity, not included. And then the range of the function. So log function in Kasra, it is not special case. Therefore, it always negative infinity, infinity. Then we can move on for the domain of gx. So actually domain of gx, we can refer to the range of fx because they are inverse to each other. So negative infinity to infinity. And range for the gx, we can refer to its domain, which is 0 to infinity. Then lastly, for the questions, D, sketch the graph of fx and gx on the same axis. So when you know fx and gx, they are inverse to each other, means to obtain their graph, we will draw the graph of fx, then we refract to get the graph of gx. So first of all, we're going to draw up what is your graph of your fx, which is 3 minus ln 2x. As we can see, its domain give us the guidance here. Hints here, 0 to infinity means it's going to the right. So function of the log is a lamppost position, so going to the right. So whether it will be inverse like this. So lamppost position, tiang lampu untuk graph log. Then when we see our log here, we have a coefficient negative, means this graph already be inverse. So here we have our graph will be like this. And what is the asymptote? You can see 0 is not included, means we will start with the asymptote x equals to 0. So we can draw out the graph here. Make sure you setting your graph precisely and accurate. So y-axis and then x-axis. Don't forget your 45 degree of refraction, y equals to x. When I draw fx, later we need to refract to get gx because they are inverse to each other. Gx is the inverse function of fx. So first of all, label your asymptote, which is x0 here, coincident. This asymptote is falling on y-axis. And this graph log have the asymptote. This is the tiang lampu. And then it's going to moving to the right hand side. So we see it have intercept here. So when we have intercept, we need to calculate x intercept, which is y is equal to 0. 3 minus ln 2x will be equal to 0. We simplify here, we given negative 3. Ln 2x will be equal to 3. So 2x will be e to the power of 3. X will be e to the power of 3 divided by 2. So here we have 10.04. So label our graph here 10.04 intercept. Then we start to do refraction as vertical asymptote. When it refract, it will become horizontal asymptote, y equals to 0. So flip your paper, or you can just fold your paper, do your refraction here to see. So supposing you can get this asymptote kaki, so the ending of the asymptote here, and then the graph is going to shooting up. So make sure your graph is symmetry in the refractions here. Then after all, we're going to label. So label every part of the function, start from origin, x-axis, y-axis, axis of refraction, and then function, and inverse function, which is our gx. So gx is given. And then finally, don't forget its intercept to 10.04. So your x-intercept, when you refract, it will become y-intercept. So after all, we see what is important here. For the first one, By using algebraic method, we want to see you substitute x1 equals to x2. And then we want to see how you simplify to find your x1 and do out your conclusion where function is 1 to 1. Then for the question B, to identify which the relationship between these two functions inverse or not, we need to see you calculate the composite of fgx. And then simplify until you get x correctly. So in other way, we want to see your g of x, how you simplify until you get your answer. Then lastly, don't forget your conclusion saying that they are inverse each other. So you must clearly state that is fx and gx inverse each other. Then we go for your domain and range. So all these domain and range bring you just 1 marks. Then when we come to the graph, firstly we're going to see your fx, whether this Tiangnam is this function of the log. So the shape of this log, is it correct? Where I need to see whether you're drawing your asymptote and your kaki of the graph, your graph getting near to the asymptote of the shape, whether it is correct. Then secondly, we need to see is it you get another function by refraction. Then lastly, we want to check whether every part of the function here is labeled. So include here. So all labeled. So number 3 marks is all labeled correctly. So that's all for this discussion. Thank you for watching.